Alright, welcome back everyone. My name is Dustin, and in the last video, we added the ThreadPool class. You can see that video right here. We're going to be putting the ThreadPool in action in this video, so if you missed the implementation, you should check out that last video or grab the code directly from the GitHub repo. Alright, so in this video, we're going to take a deep dive into the AssetPackager class. This class will help us when we're packaging our game. The goal of this class is to take all of the assets that we have saved in our project, convert them into Lua files, compile them down to Lua bytecode, then compress them into a zip archive. For the compression, we're going to be using the Libzippp library. Libzippp is a C++ wrapper around the lower level Libzippp C library. It provides a clean, object-oriented interface for working with zip archives. While Libzippp itself is very powerful, its C-style API requires manual error handling, raw memory management, and Libzippp handles all of that for us. So let's grab Libzippp for our VC package, or with VC package. Okay, so go wherever you have your VC package and then open it up in the command line. So we have our VC package. Now, I already have Libzippp installed, so we can check that with VC package list. This will list everything that we have. And if you come here, I got a bunch of stuff installed here. And if you come up here, I already have Libzippp installed. Now, what it will do, it will install all the other dependencies that you need. Okay, so what you want to do is just go VC package install libzippp. See, I already have that installed, but what it will do is this will install libzippp, and it will also install all of its dependencies if they're not already installed. So now that we have that, we can actually start adding this into our project. So let's close these, and we'll open up our project. Okay, so right here in our project, let's go to our CMake files and make sure that we add these in. So we'll go to our main CMake list here. And where we're finding packages, just right at the bottom, we can just copy this line down. And we can change this to libzippp. And then config required. Yep, that's what we want. And we're only using this in the editor right now, so we can go directly to the editor. So let's save that. It'll try to find libzip for us. Then go right to our editor. Go to our editor CMake list. Down here at the bottom, where we are adding in right here, not the include directories, not the sources, the link libraries right here. We're also going to want to add in libzip. Oh. And I'm just going to build it just to make sure that everything builds correctly. All right, so everything builds correctly. So we can close this as well, and that's good for now. So now that we have libzippp installed and set up, we can actually start our asset packager. So let's go to our packager folder in our editor or packaging folder and add these in. So we're going to want to go new file, and it's going to be AssetPackager.h. Yep, we'll add it to our CMake list, and then we want the CPP file as well. Add new file, AssetPackager.cp. Add this as well. Go back here, pragma once, namespace, ion editor. Grab this here, include AssetPackager.h, paste that in, and go back to our .h file. Awesome. All right, let's get started. So we're going to need to have the rapid JSON document. So include rapid JSON, and that's the document. Now we need this because we will want to pass around the rapid JSON value object for the assets. Okay, we're going to pass it around by a reference. This is basically where our assets live in the project file, and we'll go over that shortly. And we're also going to want to forward declare some Scion utilities. Right here, we're going to go namespace Scion util, and we're going to need the asset type enum. So we can just go enum class asset type. And we're also going to want to have the ThreadPool. So class ThreadPool. Wonderful. All right. So we're also going to need to forward declare the Lua serializer because we're going to serialize all of the assets into a Lua file. Okay. So we want to go namespace, Scion file system, then that's class Lua serializer. Awesome. OKD. Before we actually make the AssetPackager class, I want to make a simple struct for the AssetPackager params. Okay, that's going to be struct AssetPackager params. OKD, and we're going to need the asset path. That'll just be a string for now. std string. Probably gonna have to include string at the top. Cool. And it's just going to be the assets path. Oh, we just want this to be empty. Next would be the temp file path. This is where we're going to put all of our temporary files that we're creating during the packaging process. Now, we're going to create multiple different files, but we're not going to need them. They're going to be temporary, and then we're going to want to delete those at the end of the packaging process. Okay, so we want to go std string, and that's going to be s temp file path. File path. Cool. Then the next thing we're going to need is the destination path. This is where the final package game will be and where we will place all of our finished package files. So we can actually just copy that down and change this to s destination path. And lastly, we're going to need the project path. Copy that down as project path. Okay. Now we could send in the project info stuff here, but I'd rather just have these separate and just pass in what we need. Now that we have that, we can actually create our asset packager class. Let's do that. We will go class asset packager. Awesome. Let's actually make this a little bit bigger. Not too big. There we go. And we're going to have some public, and we're going to have private members. OKD. And let's quickly add in our member variables. So we're going to have the asset packager params. It's going to need the params. And we'll just call that m params. And we're also going to need a shared pointer to the ThreadPool. Okay. That will be std shared pointer Scion till ThreadPool mp ThreadPool. Awesome. That's all we need for variables. So now let's actually create our constructor. The constructor is going to be pretty straightforward. It's going to just take in. So we're going to go asset packager const asset packager params reference params. And it's also going to take in the shared pointer Scion till ThreadPool the ThreadPool. Awesome. So we have our constructor, and we're going to have a destructor. Okay, so I only want one function actually exposed outside of the asset packager, and that's going to be called package assets. So we can go void package assets, and this is going to take in a const rapid JSON value reference for the assets. Okay, and we're going to have to grab this and pass that in, and we'll deal with this throughout every function call. And we'll go over this very shortly. The main method will convert, compile, and package all the assets, okay? The rest of the functions that we're going to need are going to be private. So let's add in another section for private functions. And the first function that we're going to need is going to be the convert asset to Lua table. This is going to do exactly what it says. It's going to take the asset, convert it into a Lua table, and this is a helper function that will help us serialize the assets. So we can go void convert asset to Lua table. And first thing it's going to take in is the Lua serializer, and it'll take this in as a reference. So it's going to be Scion file system Lua serializer, reference Lua serializer. Next, it'll take in the asset name. That's const std string reference s asset name. And we're also going to need the asset file itself so we can parse the data. Okay, so that's const std string reference s in asset file. And lastly, I'm going to want to know the type. Okay, that's going to be a scion util asset type, and that's e type. Cool. So we have our convert asset to Lua table. Then we're going to want to create a function that will set up the creation of all of those asset files. So we're going to have one that goes void create Lua asset files, and that will handle all of that. Okay. So we're going to need the project path. That's going to be const std string reference s project path. And we need this so we can create the content path. Again, we already have the project info struct, and we could send that into the AssetPackager for that to gather that information. However, I've already created this class before I made the changes to the project info. In order to handle all that, I'd have to do some refactoring, which I might come back and do later on. But for now, we're just going to handle it this way because I know I have it working. So we have our project path. Then we're going to need the assets JSON object. So we know to go const rapid JSON value reference asset. Cool. Next, we'll have the compile Lua assets function. And this function will take all of the created Lua asset files that we just created and compile them down to Luac bytecode. So this will be bool compile Lua asset files. Awesome. Then we're going to need to create the assets archive. This will take all of the compiled Luac files and compress them into a zip archive. That'll be another bool create assets zip. All right, so now we're going to make a function that will actually do all of the work and serialize our assets. This is what would take the most amount of time, so we're going to run these as separate tasks in our ThreadPool. But I want to create a simple struct that will return the status of the packaging, okay? And this could just be a private struct. We don't need it outside of the class, so we can go struct asset package status. And the first thing I'm going to want is the error. If there are any errors during serialization, we want to set that here. I'm going to go std string s error. And then next would be the success flag. Okay, so I want to go bool be success. That can start as false. Awesome. So now that we have that struct, we have all our stuff here, I can create the actual serialized function that we want. And that's going to return the asset package status. And it's going to be serialize assets by type. We're going to serialize all the assets based on their type, and that's why I want to do them on different threads. Okay, so if we have, we'll get in the rapid JSON assets file here, or object. We'll get in the rapid JSON asset object, and then that will be for, say, textures, and then we'll try to serialize every single texture, and then every single piece of music and every sound effects. They'll all be done on separate threads, and they won't conflict with each other because they're different assets going to a different file. Okay. First thing I'm going to want to set in here is the actual const rapid JSON value reference assets. So we're passing in our assets. We're going to take in the const std file system path reference. This is going to be the temp assets path. And we're going to have to include file system up here. I really need to make that PCH, and we'll do that very soon. Go back. Then we're going to need the asset type name, okay? Now, this will just be a string, and this will just be so we can access the asset member from the JSON object. So we need const std string reference as asset type name. Okay, and we're going to need the content path as well. This is in order to create a full path of the file from the relative path that is held in the project file. Const std string reference s content path. And lastly, we will have the asset type. So scion till asset type e asset type. All right, Control KD, we got all that stuff. All right, so that was a lot. Now we can actually define all these functions and start putting it all together. So let's grab all of this and see if it will work for us. Create, go to our CPP. Awesome. Okay, so we're going to have some includes here. So let's go up here and go include, and we're going to have the Scion utilities. We're going to have the Scion utilities. We're also going to need the ThreadPool, which is also in Scion utilities. We're going to need the Lua serializer. So include Scion file system, serializers, Lua serializer. We're going to need the helper utilities. Might as well do that here. Helper utilities. We're going to need the script compiler. That's already in Packager. Script compiler. We're going to need the logger. Logger. And we're going to need FMT format. And lastly, we're going to need Libzippp. Libzippp. Awesome. Let's do some using. So using namespace Scion file system. And then also namespace fs equal to std file system. All right. That was a lot there. This one's pretty straightforward. We just wanted to do our constructor here. So m params equal to params. And then mp ThreadPool is equal to the p thread. AssetPackager destructor can actually just be default. Okay, let's actually do the packaging of the assets. So here, we're actually going to want to put this into a try catch because the create Lua assets files function can throw. Okay, so we want to go try catch, and we're just going to catch a const std exception reference ex. Cool. And that's going to have our Scion error failed to package assets and take in the error x.what. Awesome. All right, so here we're going to have the create Lua asset files. That's going to take in the m params .s project path, and it's going to take in the assets JSON object. Awesome. Then we're going to compile our Lua asset files. So if not compile Lua asset files, we can say Scion error failed to compile the assets. Return, no need to continue. We need them compiled before we can actually create the zip file. So if not create zip, or create asset zip, sorry, then I'm going to want to have a similar error, just so Scion error failed to archive files successfully. And then return. Awesome. And that's it for this function. So this is going to call and handle everything for us in the background. Okay. So now let's do the first one here, and that's convert asset to Lua table. This one is the big one that's actually changing the asset from a binary file or like a PNG, MP3, or whatever it is, and converting it into a char array. But I want to do it into a Lua table. Okay. So the first thing we're going to want to do is actually open up the file. So we're going to go std fstream. We'll call this in. And it's going to be in asset file, and it's going to take in std ios in std ios binary. So we want to open it as a binary file. Then we need to check if not in dot is open. I actually want to throw here. I want to go throw std runtime error fmt format failed to open file as in asset file. Awesome. Otherwise, I actually want to get the asset path. Okay. We go fs path. I'll call this asset path. That takes in the s in asset file. So now I need to create some variables for reading in the bytes that we have, and that's going to be an int read byte. That would start at 0. We also want to keep count of which byte that we're currently on, and that can be std size t I. That can be 0. Then we can copy this down and create the count. Now the count, I am only using that for which line I'm on, or which for the rows. So if I have rows, I only want them to have 100 in each row. So every time it gets to 100, I want it to go down to the next line. And then we're going to want to start our Lua serializer. So we want to go try and then catch const std exception reference throw std runtime error fmt format failed to write to path or at path to asset file error. It's going to be s asset num. This is supposed to be asset num here. Sorry. Not the name, because which asset number. Okay. Go back here, which could be nothing. It depends. I tried different things when creating these files. This is actually asset num. Okay. Go back here, where we don't need to actually have the number, but we can have it anyway. S asset num, s in asset file, and then x dot what the error. Cool. So this will throw, and it'll be caught on the outside of the, because this is in a try catch here, so it will be caught outside. All right. Well, it will be caught outside. All right, so let's actually finish this function. So now that we have the try catch and we have our Lua serializer, so we want to go Lua serializer dot start new table, and it's going to be the asset num. So s asset num. Okay. So which could be an empty string or it could be the number. So it would be something like this. So we'll have like assets equal to, and if we're having an asset num, if it's not empty, we'll make a num here 1 is equal to, and then the asset data here, right? If that makes sense. That'll be Lua. So start a new table for the asset num. Then we want to go add key value pair of the asset name. We'll do that here, and that will take in the asset path dot stem dot string true false false true. Then we want to do the asset extension, add key value pair, asset extension, and that's going to be the asset path dot extension dot string. That's going to be true or add new line. False, it's not the final value. False, not quoted, and true. And lastly, the asset type. So it would be add key value pair asset type. Now I believe we have the Scion util asset type. We don't have asset type to string, so we're gonna have to create that. So let's go to our Scion utilities.cpp.h, Scion utilities.h here. And oh, it's random generator. Whoops. Scion utilities.h. Scroll down. So we have our asset type here, and I don't have that function. Oh, looks like I didn't create it. So let's put this right here. It's good. We can go std string, and we can go asset type to string. That just takes in an asset type. The asset type. Cool. And then we can go the opposite way. So asset type to from string to asset type. Const std string asset type. So let's create these. All right. So these functions should be pretty straightforward. We're just going to use a switch. Now you could make a static map or whatever, but we're just going to use a switch statement. Switch e asset type. And it's just case asset type texture turn font font sound effects music music. We do have a scene. We're not gonna have to worry about scenes, but we'll put it here anyway. Scene shader prefab in here. Yes, it is. Might as well put that as well. Prefab and no type. No type. Type. Otherwise, we just want to return cool. And then we want to do something similar for this, but we don't need this right now. String to asset type. We do need this, so we'll take that as a little challenge for yourself. Just try to implement this. All right, we can go back to our AssetPackager.cpp and we can use this function. So let's grab this, go back here, take this. This will be Scion util, asset type to string. That takes in the E type. At least that's what I call. Oh, just E type. E type, and then we go true, false, false. Awesome. So now we can actually start serializing the data here or creating a data table. So let's go Lua serializer dot start new table. That'll be the data. So now what we're going to want to do is loop through all of the bytes from the binary file and add that into our table. Okay. We're going to go while the red byte of in.get is not equal to end of file. So I want to keep rows at 100, keep rows at 100. And I can go if count is greater than or equal to 100. And I want to go Lua serializer dot add words. True. So I'm making it have a new line with a comma at the end. And then I want to reset my count. Count 0. Awesome. Okay, so now we want to add the red byte to the data table, and we want to format this as a hexadecimal value. So we want to go Lua serializer dot add value, and we're going to use FMT format, and we want to format this value as a hexadecimal value. So we're going to want to go like this, 04X, pass in the red byte, and false. So what this is doing is it has the 0 is to pad with zeros if necessary. The 4 is to ensure a total width of the output is at least 4 characters. This includes the 0x of the hexadecimal value. And the x is to format everything as a lower case. Okay. And then once we have that, we want to go plus plus count and then plus plus I. Cool. And that is it. So once we get outside of the while loop, so what this is going to do is going to read in every byte with the .get function here. It's going to give us each byte, and it's going to check to see if it's the end of the file. If it's the end of the file, it's going to break out of the loop. And while it's doing that, it's going to grab all of our data and add each as a hexadecimal value to our data table. And then once we're outside of here, we can go Lua serializer.end table. And this is our data table. Then we want to go dot add key value pair. This is the data end. This is just I minus 1. Then we also want to do the data size, add key value pair, data size, I. And then we want to end table. And this is ending the, we can actually put stop here. This is the S asset num. Okay. And if we don't actually have an asset number, it's just going to be the table, if that makes sense. So say we have this here. So we'll have a Lua table, assets is equal to, and it'll be another table like this. Then here we'll have another table inside like that. And then all the information for the table will be here. So asset name, like that, right? So this here is, if not numbered, we can have a number here, 1 equal to this. If it's not numbered, it's implicitly numbered, okay? So we can get rid of this. Awesome. So we're catching, and that's it for this function. Awesome. So all this is doing is converting our asset to a Lua table that we can deal with and we can mess around with later on. Okay. So now here, why is that angry? Oh, yes. This is angry because it's saying asset package status, but it doesn't know what that is. So we need to actually, this is what it needs. Cool. So now we have our create Lua asset files. This here, this will actually end up calling this function. Let's go down here. And I want to actually create the Lua asset files. The first thing I'm going to want to do is check to see if the temp file actually exists. So let's go if not fs exists of the fs path m params dot s temp file path. Then I'm going to want to throw here. I'm going to want to go throw std runtime error fmt format failed to create Lua asset files temp path does not exist or is invalid and params.s. Cool. Otherwise, we want to actually make our asset path. So go fs path temp asset path fmt format. That's going to be our m params.s temp file path separator, and then assets. Then m params dot s asset path is equal to temp asset path dot string. We want to make sure that it exists, and if not, create it. If not, fs exists temp asset path fs create directories temp asset path. Awesome. So we created our asset path. Now we want to do our content path. That's the std string s content path equal to s project path that's passed in path separator plus content. Now we should verify that this exists. So let's go if not fs exists s content path. Should actually throw here because we need the content path, right? So we should go actually just copy this here, paste this in, failed to create little asset files. Content path does not exist or is invalid. S content. Change this to a path. We could probably change this to a path throughout everything instead of using strings. That could be an optimization that you guys could add in later. Okay, so now it's time to actually add these into our thread pool. What I want to do is actually create the asset futures, okay? So what I want to do is actually create a vector of futures of the asset package status. Now, the reason I want to do this is because even though I want to put these on different threads and use our thread pool, I don't want to continue because if we continue past this part, we need all the assets already as Lua in order to compile them. So I want to go std vector of std future of asset package status, and we call these asset futures. Looks like it doesn't know what a vector is right now, so let's go up to the top. Let's include vector, and we can go back down right here. So we have our asset futures, OKD. And what I'm going to want to do is I'm going to enqueue some tasks in our thread pool, and we will wait for those once we're done. Because even though we need to stay in this function, if we have lots of assets, putting them over to get packaged on different threads will help us a lot. Rather than doing them sequentially, we can do them asynchronously. Okay, so we want to go asset futures dot place back the MP thread pool enqueue function. It's going to capture reference. And we want to return serialize asset by type. And it's going to be the assets. And it's going to be temp asset path. It's going to take it. This one is going to be for textures. We're going to have our content path as content path. Then we need to send in our scion till asset type. And then, bam. All right. So what that's doing here is where the enqueue function will return the asset package status. So this is actually going to return a future of asset package status for us in our vector. So what this does is, if you remember, we're emplacing a package task into our thread pool for every thread to use, for the threads of our thread pool to use, however many threads that you created based on your system or your hardware concurrency or whatever you set it to. Okay. So we have that, and then we can just copy these. Let's actually get some space here. Great. So we can do the other assets. We can just copy this, paste it in, and this one's going to be the sound effects. S content path, change this to sound effects. Paste it down again. Our music. Music. This changes to music. And lastly, the fonts. Those are the only assets I care about right now. Fonts and font. All right. Basically, we had those 4 tasks sent out to do some work. It's going to loop through and do all the serialization of the assets for us, which can take some time because this is going to handle all of this as well, where we're actually creating the data tables, and depending on how big the file is or how many there are, those can take some time. That's why I want to do them separately, okay? So what I want to do here is actually now go through a for each one and check each status, okay? And we want to go bool B has error, and it's going to be false. Then I'm going to want to say std string s error string, okay? Then I want to use my ranges library. I want to go std ranges. I want to go for each of the asset futures. I'm going to have this function here. It's going to be the auto. That's going to be my future. So we have our function. And for each future, I want to go try. I want to catch anything here. So if there's any errors at all, I just want to go B has error equal to true. And I just want to concatenate any of the errors from the status. Okay. S error string plus equals failed to serialize assets. And this one will be the unknown when error. Give it a new line. Then here, I want to go auto status is equal to future.get. Now, the get function is a blocking function, which is fine for us right here. I don't mind it waiting here because it's going to be doing all of these assets for us asynchronously. So then we want to go if not status.be success. I want to go B has error is equal to true. So if any one of these aren't successful, we need to let it know why. And I want to go S error string plus equals status dot S error plus a new line. All right. So what this is going to do, it's going to loop through all of our futures that we have, that we in place back, and it's going to wait for their status. So all of these will do their work, and then we'll get them all back and ready to go. We still need to wait for all of them to finish, but that's okay. And then down here, we want to go if B has error, Scion error, failed to serialize assets correctly. Error string, S error string, sorry. Now we have this error here, and this create Lua asset files. We should actually throw, right? So I shouldn't even have the silent error here. This should actually be throw std runtime error. This should be fmt format. There we go. All right. We are almost done. Well, there's still plenty of work to do, but we're almost done. Now it's time to do the compile Lua asset files. And what I want to do here is go script compiler, on a script, compiler. And now we're going to want to loop through the assets path and grab all of those files and now add them into our script compiler. Okay, so the asset path is going to be where we put our files. When we're actually creating the Lua data files here, when we're actually doing this, these are going to be called whatever the asset name is, plus, so as you see here, we have in asset file, plus it's going to have the .s2d asset extension. Now the S2D asset extension is just a Lua, it's just going to be a Lua file with just a different extension that we created. Okay. So let's actually start running through this. So we're going to go for const auto reference entry in the fs directory iterator fs path of the m params dot s assets path. All right. Any directories we're going to want to skip. So if it's a directory, we're just going to skip it. So go if fs is directory of the entry. Continue. Then we want to check to see if it's a regular file and if the extension is equal to our S2D asset. So we go if fs is regular file entry.path and entry.path.extension equal to .s2d asset. Then we want to do some stuff to it. So what I want to do here is I want to go if not script compiler dot add script. And it's going to be the entry.path.string Scion error failed to add script to AssetPackager. Tree path dot string. Then we can return false. All right. Otherwise, I want to go script compiler dot set out file name. That's going to be std string of the fs path and params dot s temp file path std string entry dot path dot stem dot string plus dot luac. This needs to be, and let's put this in a. Okay, so all I'm doing here is I'm making a path and I'm concatenating the entry name and taking the stem and then changing the extension to be a .luac. So it's taking our S2D asset name file and changing the extension of it for us and setting that as our output file name. And we're putting this in our temp path. Okay. And then now we have that, we can go script compiler.compile. And then we can clear scripts. Script compiler clear scripts. Awesome. Now what this should do is it should end up making 4 files for us for the, or is it 4 files? Let's see. Yeah, it's sort of the fonts, music, sound effects, textures, and eventually shaders and stuff. But however, we can't really run shaders on individual objects and things right now yet, or custom shaders. Eventually we'll be there. But right now it's just these 4, and that's what we need. Cool. And if it does all that, we can return true. Awesome. All right, we're getting there. So now it's time to create the asset zip. So what I want to do here is create a path. So we're going to go fs path. That's going to be assets. This destination. That's just m params dot destination path. What do we call that? All right, we'll just go here and see destination path. Back and params destination path. Cool. Then we want to check to see if it exists. If it doesn't exist, we want to try to create it. So if not fs exists asset destination, get the error code. Error code PC. Then we can go if not fs create directory, create directories, asset destination. Scion error failed to create directory. And return false. Awesome. And now we can actually create our zip file. And I'm just going to call these the Scion assets. So we can go assets, destination, or equals, these would be a string, Scion assets dot zip. Then we can take our libzip and make a zip archive. So we go libzip, zip archive, call this zip. That is assets destination dot string. And then we have to set our error callback. This is something that we need to do here. So we go zip dot set error callback. And this can just take in a lambda. And it's going to take a const std string reference for the message. Const std string for the str error. Int zip error code. Int system error code. Then here I just want to go Scion error failed to archive asset message string. Cool. Now that we have our error callback, we're going to want to open up the archive to write to it. Okay, so I want to go if not zip dot open. That's libzip zip archive for writing. Scion error failed to open zip. Zip dot get path. Return false. Now that we have it open for writing, we're going to want to add the entry. Okay, so I want to go if not zip dot add entry. Then I want to say std string Scion assets because we're adding in this new entry here. I want to say Scion error failed to add entry to we want to close the zip and return false. Otherwise, I want to check to see if all the specific files are existing. So I want to see if our textures exist, our music path exists, all these things, and then I want to add them as an entry as well. So we go const std string texture path fmt format mparams dot s temp file path separator, and then the textures dot luac. Now that should have been created. Then we want to go if not fs exists texture path, or not even if not, if it exists. All right. Then we want to add the entry or add the file. Then we want to go if not zip dot add file fmt format. First one is going to Scion assets, then our path separator, then the textures dot lua. And once we have that, we need to send in our texture path, so it knows where to get the file from. Okay, so this adds the specific file, this file here that we know exists, and it adds that into our zip file right here. The adding the entry is going to create a new directory for us. Well, if it's unable to add that in, I want to go Scion error failed to add textures dot luac to zip dot close false. Awesome. And we're going to want to do the same thing for the other folders as well, or the other files, sorry. So let's copy this, let's paste it down, and we can change this to the music path or the sound effects path. It's all the same. So music path, music path, music path. They'll do add music. Copy again. Paste. Sound effects. I believe that's how we spelt it up. Sound effects like sound effects, sound effects, sound effects, and one more for the font. Paste. Awesome. And then all we have to do is go zip.close and return true. Awesome. We are almost done making at least making the asset packager. We still got to test it out. And the last part is the actual serialization of the asset by type. Okay, so what I want to do here is actually create the asset file. So let's actually get rid of this for now. We go const std string s asset file. That'll be the asset type name plus s asset plus dot s2d. Cool. So that'll create the asset file name for us. Then we can create our asset path. So fs path asset path equal to temp assets path, passing in that path. And now we can create our Lua serializer. So we go std unique pointer Lua serializer, the Lua serializer. That could start as null pointer for now. The reason why I want to declare it here, the Lua serializer can throw. So I want to do this in a try catch. So I want to go try the Lua serializer is equal to std make unique Lua serializer. That takes in the asset path string. Now we're going to want to catch, and this is just a const std exception dx. Then I want to go std string s error. That will be fmt format. Now, the reason why we want to make the error this way is because this returns a asset package status, right? So I want to make sure I'm getting the error and adding that to the package status. So I have our format, and then I want to go failed to serialize asset. Let's get the error. X.what. Awesome. Then I can go return s error false. So it is not successful. Awesome. So now I need to check the assets rapid JSON value to see if it has the member of the asset type name that's passed in. Okay. So if we go if asset dot has member s asset type name dot c string, then I can go const rapid JSON value reference asset array is equal to assets at s assets type name dot c string. Then I need to verify that this is an array. It must be an array. We need to go if not assets array dot is array. Then I need to do the error again, so we can actually copy this here, paste that in, and this is going to change. Here we're going to go failed to serialize asset file expecting must be an array. That's going to be temp asset path dot string and the asset type. Control KD. And so basically what I'm saying here is, hey, this asset type needs to be, this data member needs to be an array. If it's not an array, then it has to fail. Okay, because we want to loop through every member of the array or every element of the array and serialize that element. Otherwise, we now want to start a new table. So P serializer, P Lua serializer, sorry. Start new table. And this is just going to be S2D assets. So we started our table and I want to go try. And here we'll go catch. It's going to just be an std exception. And what I want to do here is now loop through each of the JSON values of the array and send it into our convert asset to Lewis table. Okay. So I want to go for const auto reference JSON value in the asset array dot get array. And for each value here, we need to create the path that we want to send in. So that's std string s path s content path plus path separator plus the JSON value at path dot get string. And then I can go convert asset to table. That takes in my serializer. It takes it in as a reference. It takes in the asset number. And we're not going to use asset numbers, so we're just going to send in an empty string. And then we need to send in the path, s path. That's the actual asset file itself. And then we need to send in the e asset type. Awesome. So if there's any errors that happen at all when we're converting to the table, we need to catch that. So we can copy this one again. Actually, let's copy this one. That makes more sense. Here. And here we can say fail to convert asset to awesome. All right, so if it makes it out of here, we can go p Lua serializer and table, and this is the s2d assets that we created. Awesome. And then if it makes it here, we want to go return b success true. Now feel free to add the .b success and stuff here. We can do that. We can go like this and .s error that. I can actually copy this for not return. Get rid of that. Go on up. Right here is good. Awesome. All right. So much to do and finally finished. So that's everything that we need for the asset packager. Now we have to test it out. Now I didn't think about testing it out when I was writing up the video for this because the way that I did it was I just did it all at once. I created the packager, did everything like that. So we're going to have to just do this on the fly. I kind of got an idea of what I want to do. So before we start adding to it, let's actually just build this to make sure it still builds. Okay, so we go to open project. So everything built fine. We don't need to do any of that yet. So let's close this. Close it. So the build is fine. So now I can go to my package display. So let's do that. Go here, go to our displays. Let's go to the package display here. Let's add that in. So here we can go include editor / package. And now I want the asset packager. Cool. And we just want test data for now. So let's go down here to our package game. And the first thing I need to do here is go asset packager params. We need to pass this in. And that's just going to be the asset packager params. So we need to make this. So first is going to be the temp file path. So s temp. Oh, why is it not like that? Assets package. What did we call that? Let's go back here. Packager param. Back here. Paste this in. S temp path. And that's just going to be the project data path. So we need to get our project info. So here we want to get our project info. So to get our project info, I want to go auto reference p project info. Looks like we're already getting that somewhere. Project info. Yeah, so we're getting it up here on the outside. So we don't have to do that. We can just grab this. Get rid of that. So we have to create our temp project path. So let's go P project info, get project path, or temp data. We can go auto temp project path, temp file path. Yeah, temp file path. Let's actually not do auto here. Let's go fs path. Then we have our path, and I can go string. That's our temp path. Then we need the destination. And the destination, I'm actually just going to do the same thing right here. And I'm just going to say, instead of temp path, I'm going to go temp destination. Because this is just a test. We don't really care right now where it goes. Eventually, we'll be able to pick from the UI where we want to actually put the file. So temp destination. Destination. Then that's S destination. Destination. Oh, why do I keep forgetting what that's called? S. Oh, it's because I didn't put a T in it. That's why it keeps coming up wrong. So this should be destination. Destination. Let's go fix that everywhere. You guys probably caught that already. Oh, and let's go back to our package display. So we have our destination path. That's going to be equal to temp destination dot string. Cool. Then we're going to have our project path. That's equal to just the project path here. And what was the last one again? So the temp file path, assets path, and that's created for us later on. Cool. So if we go back here, then from there, we can actually create our asset packager. So asset packager, and we can say asset packager, that takes in the asset packager params. And we also need the thread pool. So let's go up here and get the thread pool. So let's go auto reference p thread pool equal to main registry dot get context, and that is the thread pool pointer, I believe I called it, or shared thread pool. Shared thread pool. Yeah, I think that's what we called it. So that means I need to include thread pool. That would be in Scion utilities here. That's thread pool. Go back down. I believe it's called shared thread pool. Let's actually verify. So let's go down here in our utilities, thread pool. Down at the bottom, shared thread pool. Yep, I was correct. Okay, so back to the package display, get our shared thread pool. Whoops. Now it should be valid because we already added that in. We add that in the application. So let's check just to verify. I don't want to have to do the check and do all this stuff later. So application, where are we adding in our thread pool? Right here. So we're adding in the thread pool right here, and I'm only giving it 6 threads. That's plenty. So we go back to the package display. So we get our thread pool, and I can pass that in here. Awesome. So we have the thread pool, and then we can package our assets. We got to go asset packager, and then I can go package assets. Now this takes in the assets rapid JSON value. So we need to get that. In order to do that, we have to open up the project folder. So I'm going to want to go, and we might as well just do this up here. And we can go std if stream. We'll call this the project file. proj file. Then I can go, oh, it doesn't know what ifstream is. So let's go up to the top. Let's just include fstream. Go back down. Okay, so we have our proj file, and I want to go proj file dot open. And now we need to get the project path. And we can get that from our project info dot, I believe we can. Let's go to this file. Go over here. So we have right here, get project file path. That's what we need right there. And it's going to be an optional. Keep this around. So before we just shove it in, let's actually go back in and let's not just shove it in there. Let's go here. Let's go auto project file path equal to the project info. Now it's probably going to be there, so let's just verify. On assert project file path. Should be assert, sorry. Project file path not set. Project info. Don't need to do that. We need to just dereference project file path string. Or no, we don't even need to dereference it. We just do the string. Get rid of this dereference. Cool. So we're going to try to open our project file, and then we want to go if not proj file dot is open. Say we can't open it. Scion error fail to open project file. Sure, good enough for now. And we can just return because it's not doing what we want. Might as well just return. And now we need to read everything in for this project file. Might as well do it here. std string stream. Proj file. Read the buffer into the stream. I'm going to go std string be the contents. Then we can go and get a rapid JSON string stream. Rapid JSON string stream. This will be our JSON string of the contents. C string. All right, then we want to get a rapid JSON document. Rapid JSON document doc.parse stream. And we won't really worry about error. Well, we will. We'll just go if doc.has parse error or doc.is object. No, it is not object. Scion error. Now, all this is just for testing. We need to get the project file so we can get all the assets from there because all the assets should be saved in the project file. None of this will be in here later on. Eventually, this will go to the packager itself. Okay, so Scion error. We could just say failed to load asset files. Sure. Turn. Otherwise, let's check to see if we have our project data. So if not doc.hasMember project data, well, then this is the wrong file. Scion error does not have project data. Turn. Now we can grab the project data. So we go const rapid JSON value reference project data equal to doc at project data because we know it has it. So we have our project data. Now we want to make sure that it has the assets member. I know it's a lot of stuff to do, but we might as well just do this. Change this to the project data. Has member, assets. If it does not have the assets member, then we can say project data does not contain asset. Cool. And then the last thing that we need to do here is actually get the assets value. Okay. So we can copy this here, copy that, change this to assets, take this project data, cut that, paste it here, change this to assets. That's equal to project data at assets. That's a lot there. Okay, so now we can take this assets and plug it into here. All right. So it was a lot to do, and I'm not even sure if this test is going to work because I never even tested it like this. The way I tested it was I just kept going. So I made the packager and I did it all in the packager and all that stuff. I didn't actually test it one by one, but I'm making a video and teaching, so or should at least going through the process. So we have to test because it would be suck to have to do another 2-hour video before you even see anything going happening. Okay, so let's see if this works, and this should open in our project path. Okay, so let's open this. So I want to open my project, and I have a local project right now that I have here. So I might as well open that folder as well. Okay. So I have this open right now on the side. Why? Because our temp folders should go in here. Okay. Let's load this, load project. And this has a few assets in there. It has, I believe it has some music. Yep. Has some stuff, has some scenes, right? Now, these scenes are just for testing this one as well. Let's go to our package game, and I just want to test this. Okay, so let's bring this over here, and I will hit package. And actually, let's go to logs first. Let's clear any logs that we have, and we'll just package it and see if we have any errors or any crashing or anything like that. Package. Okay, so we have an error here. Failed to create Lua asset files. Float temp data does not exist. So did it not create that folder for us? Did not. Failed to create package. Oh, the temp path did not get created. And let's see why. Let's exit. Temp path. Right here. That's it. So where are we creating this? Taking us everywhere. Yeah, they made some changes to Visual Studio. I dislike the changes. It should just stay in the file that you're on. Okay, so AssetPackager. Oh, yes, that's right. So I was creating the temp file path in the packager itself because it's used for more than just the assets. That's why we don't see it right now. So we actually need to create that before we start. Okay. And we'll create the destination path as well. Unless, are we creating the destination path down here? I don't think we are. I think it's already should be created. S destination. Okay, so I do create the destination path here, even though other stuff will be going to that destination as well. So it actually should be created outside. But we'll handle this now. So let's go back to our package display here. And we have our temp file path and our temp destination. So the destination should be made. So before we do this, let's go fs. Let's go if not fs exists temp file path fs create directory temp file path. Cool. Let's try running it again. Okay, so open project, back to where we were. Cool, we can just go right to package game because everything's hard coded right now. It won't be later on. Later on, it'll take in everything that we need. So package game here, here are our logs and package. Awesome. So it looks like it created everything for us, created all of our stuff. Now let's actually see if it actually did. Okay, so we have our temp data, we have our temp destination. Those were made successfully. So if we go inside of our temp data, we have all of our Luac files, and it has these assets here. So it has the S2D. These were the actual, these are the Luac files that were compiled afterwards. See, the music's huge, the texture is huge. The other ones are small because they're basically empty, right? So, but then we have our asset file. So if we open this up, it's just a Lua file, right? We can open this and we can go to edit with Notepad. Sure. And if I bring this over here, all it is a Lua file, and it just took our data and all that stuff and stripped down the bytes, and there's all of them are in here, right? So it's got the objects one, it's got all of them are in the one file. So it takes that into the one file here and then compiled them into Luac. Okay. So if we go and open this as well, so it's just compiled down into Luac. So we can actually load this now. When we have our packaged game, it'll actually load these files instead. And the other files, these asset files, will all be deleted, right? So these Luac files should be copied into our zip folder. Our zip folder should be in our temp destination. Let's check it out. There it is. So there's our zip file, and this should have our Luac files that we created inside. Bang, there they are. All right, so everything is working exactly as expected. It was a lot of work to get through this one. A lot of things are happening, but we're able to zip all of our files up. And now when someone opens this, we'll be able to decode all this in the engine when it starts to run these files. But if someone wants to just come and look at your sounds or whatever, they're going to have to figure out what it is and how to do it and how to use it, right? Because this is all Luac. So it's compiled. It's a bit harder. Like, people can figure this out, but it's a bit harder, more of a step to actually figure it out. Okay, so that's it for this video. In the next video, we're actually going to start creating the packager itself and some other tweaks and stuff as well, but we're actually going to get that together. This won't run on the same thread. Right now it's running on the same thread. The packager itself will be run on its own separate thread, and we're going to get that into that in the next one. All right, that's it. Make sure you like and subscribe if you haven't done so already. Also, leave a comment below, and if you have any questions or concerns, please let me know. We also have a Discord channel. You can check that link out in the description, and that's it. All right, take it easy.